I'm Anil Kumar. In this video, I'll explain how to write equation of a rational function from given conditions. And I will also show you how to relate the conditions with the sketch and then write the equation. These are all interlinked. This is the question from my subscriber Owen, and I hope it will help many others. So we have 3 questions in it that may help to understand the concept. First 2 are based on reciprocal functions, and then we have a simple rational function with linear numerator and denominator. So let's begin. The first one here is determine an equation of a linear reciprocal function with vertical asymptote at -4 and y-intercept of 0.5, that is half, right? So you could write this as half. Second is determine an equation of a quadratic reciprocal function with vertical asymptote at ±1/3 and y-intercept of -4. Third one is write an equation for a rational function that has a graph with x-intercept of 5, y-intercept of -5/8, vertical asymptote x equals to -8/3, and horizontal asymptote y equals to 1/3. You can actually pause the video, answer the question, and then look into my suggestions. So let's develop an approach to solve such questions. The first one here is determine an equation of linear reciprocal function. That means what? We're looking for something, let's write, we are looking for something which is 1/mx plus b, right? So reciprocal of a linear, that's a linear reciprocal function. What are we given? Let's have a look at what is given to us. It says with vertical asymptote at -4. So let's say that's the coordinate axis, and we have vertical asymptote at -4. That means -4 is kind of like this on this side, okay, and y-intercept of half, which is positive, so positive will be somewhere here, right? So y-intercept of half is somewhere here. Now if I connect these points, I could actually sketch a graph which could be kind of like this, right? Taking care of the y-intercept and the asymptote. Now the idea is that this is the graph of a reciprocal function. So how should the reciprocal function be? Clearly speaking, on this side of the vertical asymptote, which is the right side, line should be positive since the reciprocal is positive, right? And on the left side, line should be negative with 0 at the vertical asymptote itself. So now we can draw this line. Now it's a question of finding the values. The y-intercept helps us. What is reciprocal of half? It is 2. So when I do 1/2, reciprocal of 2, I get 1/2, which is given to us. So this line basically gives us the solution to the given question. But I hope you got the basic concept of relating all the 3 things, right? Now we can very easily write down the equation. So what we know here is the slope will be, this is like -4, right? This is -4. There's a rise of 2 and run of 4 units. It's a positive slope, so it is half. You could write like that. Now I'll show you easier way of writing this equation than finding the equation of line. It could be difficult at times. Okay. From this 0, what do you get? From this 0, you get that we have an x-intercept here at -4. So we have a factor x plus 4 in the denominator, right? We don't know what is there in the numerator, so I'll put a for the time being. To find the value of a, I will use the second condition, which is y-intercept of 0.5. Y-intercept really means when x equals to 0, then y equals to half. This is what I want. When x equals to 0, y equals to half. So what should be the value of a? That is what I'm going to answer. So if I put x equals to 0, I really get a over 4. To make it half, I should write a as 2, correct? So what I get here is that a should be 2. Is that okay? And that is how I get my equation. And therefore, this function should be 2 over x plus 4. Does it make sense? So we got the answer for first one, which is that the function f of x should be equals to 2 over x plus 4. You can check for this particular function, there will be a vertical asymptote minus 4. And if I substitute x equals to 0, I get 2 over 4, which is half, and which is this y-intercept. Is that okay? So that is how easily you can get the equation from the conditions. Now let's look into the next one. It says determine an equation of quadratic reciprocal function with vertical asymptotes at these points and y-intercept of minus 4, right? So let's look into this. We'll adopt a similar approach. I'll make a minor difference here. Now, y-intercept is negative. That means what we are given here is y-intercept is negative 4. Somewhere here, let's say negative 4 is a y-intercept. And there are two x-intercepts. Okay. So we are looking for vertical asymptotes at these points. And of course, if these are the points on the reciprocal functions, I mean, it has to be kind of like this, correct? Then what should be the reciprocal of 1 minus 1 over 4? The reciprocal of this is minus 1 over 4, correct? So what we have here is a quadratic function which could look like this. Let's go through this, right? So we have a quadratic function which is kind of like this. Do you see that? So that is the quadratic function. We want reciprocal of this quadratic function. So some of you could actually get the equation of this. Write 1 over that quadratic function as your result, correct? However, my strategy will be as we did here. So we'll write this function g of x as equal to 1 over, I should say a over, right? So we don't know what a is. A over. We know these two, which is minus 1 over 3 and plus 1 over 3, correct? So that means the factor is 3x minus 1 times 3x plus 1. Do you see that? So these two factors will give me the vertical asymptotes. Now what I need to find is that the function should have y-intercept of minus 4. So if you sketch this function, how is it going to look like? Well, the reciprocal function will look like kind of like this. Reciprocal of positive part is positive. When a function is increasing, reciprocal is decreasing to 0, right? Kind of like this. So we will now write down the value of g of x. So these two are the vertical asymptotes. We have to now worry about this point, which is at 4. Correct? That means if x is 0, I should get 4 here. But if x is 0, what do I get? If x is 0, I get g of x equals to a over. If I write 0 here, I get minus 1 times minus 1, which is not 4. But if I want to make this as 4, then a should be what? This is what I'm trying to figure out. So this is, minus 1 times plus 1. So this is minus a. So minus a is 4, so a should be minus 4. You get the idea, right? So that is how you are going to get your equation. So we'll say a is 4, and therefore our function will be 4 over 3x minus 1 times 3x plus 1, right? So that becomes the function for the given condition. So I hope this is absolutely clear, right? Now let's move on and see the last question here, which is write an equation for a rational function that has graph with x-intercept of 5, y-intercept of minus 5 by 8, vertical asymptote x equals to minus 8 over 3, and horizontal asymptote y equals to 1 over 3. So a lot of information to compile here. Let's make a sketch to put it all there, and then we'll work it out. So we are given x-intercept of 5. So somewhere here the graph crosses the x-axis. Y-intercept of minus 5 over 8. Let's say a small value here, but negative, that is important. Vertical asymptote at minus 8 over 3. So somewhere there is a vertical asymptote, which is minus 8 over 3. Horizontal asymptote is 1 over 3. Let's say this. Is it okay? So this is the information. This line is at y equals to 1 over 3. This line is at x equals to, let me write here, x equals to minus 8 over 3. Okay. And the y-intercept is minus 5 over 8. The x-intercept is at 5. That is the condition. So if you look at it, what are we expecting? We are expecting a graph which is kind of like this. Is it okay? Okay, so reciprocal, let's safely put general. Okay. How do we get the equation of this function? We can begin with the conditions given to us. X-intercept of 5. That means at 5, the numerator should be 0. Is it okay? So we get this function, let's say h of x, as equals to, in the numerator, we have x minus 5. Now this will ensure x-intercept of 5, correct? Y-intercept of minus 5 over 8. Okay, so we can get back to this later because we could find the a value with the help of this. Vertical asymptote at x equals to minus 8 over 3. Let's look into vertical asymptote. So first, vertical asymptote is very critical. Minus 8 over 3, that means it is 3x plus 8, right? So that will ensure vertical asymptote of minus 8 over 3. Now we want to find horizontal asymptote 1 over 3. So when we are given horizontal asymptote 1 over 3, degree of numerator and denominator should be same, perfect. Here it is. If x is very large, 1 over 3 is the leading coefficient ratio, so that works automatically. So this is simple in this respect. Y-intercept of minus 5 over 8. If I substitute 0 here, I do get minus 5 over 8. So that condition is also met. And therefore, this is the function we are looking for. So that becomes our solution. So these are the three equations which will suit to what conditions we began with. I hope that concept is clear. Feel free to share my videos, write comments, and if you like, that'd be great. Thanks for your question. All the best.